Okay, so we talked about these total change problems last time. Total change with the concept of total change is we have a rate of change in something happening over an interval of time. So some kind of rate times some time of time gives you total whatever. Sometimes that's a distance, but anything that's changing based on a certain rate or over a certain interval of time, we can calculate as a total change. We do total change problems using calculus when we have a changing rate, something that's not a constant rate, but a changing rate, in order to take individual different rates times individual different times and add up all those little amounts. That's what takes the integral. So we integrate the rate of change times, and the dx represents intervals of time. And then we set up the restrictions on the integral as starting from time A to time B. And that's how we get our total change. Now, we've talked about this in our notes with a population change. We talked about gas flowing into a tank, number of married couples. We did the parasite growing. We did the water leaking out of the tank. The function that we haven't used in a total change yet, that is a very typical change function, are the marginals. So I want to make sure we talk about marginal problems today, because marginal functions like marginal profit, whether we're looking at change in profit over time or change in profit over amount, marginal profit, marginal cost, marginal cost, marginal revenues, those all represent rates of change. Okay. When we took the derivative of the profit, that was the marginal profit, the change in the profit. That's how we found the change in the profit at any one given time, instantaneous rate of change. Marginal cost is the derivative of the cost, marginal profit or revenue, derivative of revenue. When we start with the marginals, we can do a couple different things. We can go back to the original profit, the original revenue, the original cost function. That's one type of marginal problem we did. But we can also use these marginal functions to just calculate the change. So not necessarily that we would know here was exactly the profits in this year, this was exactly the profits in this year, but I can still figure out the difference in the profits from the 2 years just from the marginal function. I don't need the full function, full profit, full cost, full revenue to get a calculation of change. So let's look at an example of that kind of problem. Like I said, the only thing I was concerned about when I realized we hadn't talked about this type is you would see a marginal function and you'd think, okay, there was just that one kind of problem we did with marginals where we were figuring out C and stuff. And a marginal is a rate of change, so we can do a total change with it as well. All right, so let's say we have a marginal profit function that looks like this. Okay. One of the things about the marginal profit, the marginal equations in economics, is they tend to use this notation to represent the derivative versus the prime. Okay. I think it's more just the emphasis of it's a change in profit over what might be time, or in this case, items. Okay. I want you to calculate for me, given that this is the marginal profit, what will be the increase in the profits from from manufacturing and selling 100 items to 110 items. So the change, hopefully it's an increase, seems like it should be. What is the change in profits? How much are my profits going to change? Not the rate of change, but the total change, which is a slightly different question. The rate of change is a derivative question. Total change is an integration question. Okay. What's going to be the total change? Most likely, hopefully, an increase in the profits from when we did or sold 100 items versus 110 items. And I don't remember about if this was in thousands or something. Let me see if I can find this example real quick so I make sure we're talking about it like it makes some sense. Grab this right out of the book. And I didn't write down if it was thousands or not. Feels like it's going to be thousands of dollars, but I didn't know that for a fact. Where is this problem? Where are you, Mr. Problem? I don't know. Yeah, it doesn't say. I guess it's not thousands. I guess it's just... who knows? Okay. Okay, so I don't have a full profit function. If I knew the profit at certain X, I could do the antiderivative and then figure out C and figure out the profit function, calculate the profit at 110, calculate the profit at 100, subtract those. But ultimately, I really just need to do this. If I go from 100 to 110 of my profit changing function, marginal profit, that calculation will give me the total change. That will tell me the change in profits. It's not going to tell me what exactly the profits were at 100. It's not going to tell me exactly what the profits were at 110, but it'll give me enough information so that I can tell how much it changed or how much it increased. All right, so go ahead and try that. Now that we've got the setup, you're like, yawn, fundamental theorem. Let's see what you get. Oh, iced coffee this morning, so good. All right, so let me hit this with my little antiderivative powers. So let's see, so negative 0.0005 x squared divided by 2. That's a little awkward, but we'll make it work. 12.2x. Different notation. I think we were looking at this on the notes. This is just another way to remind yourself this is a calculus notation. Like, okay, I'm going to take this and I'm going to plug those into it. You don't have to write that. I just tend to do it out of habit. We can also just, I want to call it big F, but this is big P. It is the profit function, but it's missing the constant. We don't really know. So it's not the full profit function. But if I hit 110 on this profit function with my calculator, because I don't know what that is. 110 squared times negative 0.005 divided by 2 plus 12.2 times 110. All right, I'm getting 1311.75. I don't know if that's right. Well, usually the best way for me to verify that is to do it again. 0.0005 negative times 110 quantity squared, all divided by 2. I don't know if I remember. Plus 12.2 times. Yeah, now I got something different. Okay. Did you guys get 1338? Or 13? Nobody's helping me. Let's try that again. Negative 0.0005 times 110 squared divided by 2 plus 12.2 times 110. Yeah, I got that 1338 again. Yeah. That's usually why I do it more than once. If I get the same answer in a row, I know I'm probably right. If I get two different answers, I'm like, I messed something up. Okay. I think I know what the final answer is supposed to be, so let's see if we get there. Negative 0005 times 100 squared divided by 2 plus 12.2 times 100. So that's 1217.5. So the change 1338.975 minus 1217.5. 1338. So 121. Ooh, where's my eraser? And now where's my pen? $121,475. Let me check that. Am I right? Did I do that right? Guys don't want to help me. Nobody wants to help me. Nobody likes me. Just Mrs. Lowenbrock doing our work. That part, that part, later. 5. Yep, that looks good. So, okay, so 10 additional items, looking at $121 more in profit from those 10 additional items. So in an economic concept, that means we're probably not doing something right. We want to somehow marginalize this difference. We want the margin to be very small so that if we do one more, we're not really getting very much more. That means that we're actually operating at a really high level of efficiency. Because there's so many other pieces kind of that go into the profit based on production cost and revenue and then supply and demand and things. If we're going to make more money from more items, we should be operating so that we can more items. But we will get to a point, this is the theory of economics, that when our profits are might either slow or stop growing, okay, we want to get to right before that turn happens. And so one of the ways to do that is to look at this being super duper small. Okay. So 10 items, that's like about 12-ish per item. So, you know, maybe that margin is still a little bigger. Like, okay, so we could push this a little bit more to, so if this changes, then this gets a little smaller. So we know that we're operating at the most efficient way. Okay, you do have one of these type of total change questions on the practice sheet. Let me grab that practice sheet. That's this, and if you're like, what practice sheet? The second page in the little 2-pager that I gave you. The one I want to change the wording on, though, is this one. Hang on. I would like to open this function. So if you want to grab that for a second, and you've got 2 on the front where we've got, there, come over here, total change. All right, so here's our notes. Pretty sure that I've got the review pack in the second part. All right, so those are the ones we did in class. Okay, so we got the tree problem. The tree problem's got a root in it, so we got to make sure we can integrate the root. This has got a fractional exponent. So these are a little trickier just because of the type of functions you have to do the antiderivative of. Okay. Problem number 3 is the one I want to change, because actually the way this is worded is not correct. We're not calculating the profits earned over the first 9 months. We're calculating the change in profits over the first 9 months. And then we want to compare the change in profits from 0 to 9. So maybe I'm going to use that word. Let's compare the change from 0 to 9 and then the change from 9 to 16. Okay. So the change in profits you get in part A from the first 9 months, 0 to 9. I then want you to calculate, all right, well, what's the change in profits between months 9 and 16, and then what's the difference in those two changes? Okay, because what you'll see is, this is a good example of a profit that is growing, but the growth is slowing. You should ultimately get a bigger amount of change from 0 to 9 versus the change you get from 9 to 16. Okay. Problem number 4, the population question. This is just in people, not thousands of people. It will just come out in people. And I think those were all the questions. Be really careful when you do number 3, also because you've got that quotient, which is something you got to watch for, and a root. So a root and a denominator. So rewriting number 1 before the antiderivative and rewriting number 3 before the antiderivative are going to be important. All right. So what's happening on Tuesday, okay, is I'm going to collect 2 things from you. Okay. I'm going to collect this. I'm going to just use TC for total change. This total change class worksheet, which is just these 4 problems. Worksheet 1 to 4. Second page of packet. And the other thing I'm going to collect from you is the review that we worked on Monday, which has the rest of the quiz concepts on it. Now, while you're working in class today, if there's something on that review from Monday that you still need help with, this is a good time to ask. Lots of opportunities to get some extra help, and obviously help with the total change. These are the concepts that are on the quiz. We're going to collect these two and take a quiz on this. Okay. All right, that's all I've got for my part of today. Let me know what I can do to support you in finishing these items, in checking answers, and making sure you're ready for a quiz, and we'll be good. Stop my video.